Hello class, in this video we're going to be discussing 3.3, which is all about rotations. So we want to address the question, what are the properties that identify a rotation? We want to be able to draw and describe the rotation of a figure about a point of rotation for a given angle of rotation. So a rotation is a transformation that takes each point and rotates it in the pre-image about a point which we call the center of rotation by a certain angle measure called the angle of rotation. And so the symbol for the rotation that we use, at least in the book, uses a lowercase r. Remember that the reflection used a capital R, and then here you have a lowercase r, but then you have the angle of rotation that you want to use, which is the x degrees. So this indicates this right here indicates the angle of rotation, and then P is the point of rotation. So again, usually you can also use the arrow notation for transformations. Any transformation can be illustrated with this arrow notation. And that will tell you that you're taking the point xy and you're transforming it in some manner. And then they'll have another coordinate here. And that coordinate will specify, the rule that you're using. And then based off of that rule, you can determine whether it's a rotation or reflection or a translation. But in any case, let's talk about the properties of rotation. So we have here, if we were to rotate about some generic angle x about a point P, well then point P is the center of rotation here. And so the center rotation stays the same. So you're not going to rotate P when you do this. So notice that we have the triangle ABC, and then notice that for when you're trying to rotate it about point P, you're drawing basically a dashed line indicating that there is some kind of distance from P to A. And then that line has to be the same distance as the line from P to the image of the other triangle. So basically you have to measure this distance from P to A of this line segment, and then you're going to have to use a protractor to get this angle right here. Let's say it's 25 degrees, then you're going to measure that on the protractor, and then you're going to mark where that angle is, and that angle happens to be here, right? 25 degrees from here to there. From here to there is 25 degrees. And then you're gonna have to measure, now that you know the measurement of this line segment, PA, then you're gonna have to measure from P to to the 25 degree angle. And so if this were 5 inches here, then this would also be 5 inches, for example, on the ruler. So you can measure that, or you can use a compass. A compass is perfect for these kind of things because you don't have to measure it. You can just use the compass to help you figure out if they're the same distance or not. But in any case, we know that the distance has to be the same here for that given angle. So a positive angle of rotation is considered to be clockwise. So if you're going against the clock, rotating against the clock, then that's a positive angle. If you're actually rotating clockwise, that would be considered a negative angle of rotation. All right, so let's perform a 75 degree rotation about triangle XYZ about point P. We'll illustrate this point here. So step 1, we want to rotate X. We want to draw PX, a line segment PX, to form one side of a 75 degree angle. And so you'll use your ruler. So use your ruler or some kind of straight edge in order to connect X and P together. And when you connect it, you won't connect it necessarily in a solid line. You'll connect it in some kind of dashed line because it's not an official line. It's just to help us measure the angle. All right, so next, once we draw that, step 2, we want to measure the angle and draw the other side, px prime. Mark point x prime so that px prime is equal to px. So basically whatever this distance is has to be the same distance on the other side. Whatever that distance happens to be has to be the same. So we'll show you how to do that. So we want to rotate this 75 degrees. So first, what we're going to do is I'm going to mark with my, let's see here, I'm going to mark with my compass. I'm going to use my compass and I'm going to draw an arc. You can do this in several orders, but I'll do it in this order. So let me put my compass point here, and then I'll rotate it. I'm going to set my compass so it's the same distance from P to X here, or so it's the distance from P to X. Okay, and there's my arc somewhere around there. And then I'm going to go ahead and I'm going to draw, I'm going to draw an arc. It should be a little bit longer here. Okay, I'm going to draw my arc. And I don't know where the 75 degrees is, but you can kind of get an idea of what 75 degrees is. This is definitely more than enough for 75 degrees. Remember, a full circle is 360. So if it's past a quarter circle is 90 degrees. So this should be more than enough. If we need more, then we'll add more. Okay, so then what we'll do is, well, we know that we need to measure 75 degrees. So I'm going to take the protractor here. I'm going to line it up. I'm going to try to line it up like this so that I can measure the angle. So line up the leg like this. Line it up with the orange here. And then, so we're going to be using these bottom numbers here, or I guess in this case it's top numbers. So 10, 20, 30, 40, we're going to be using that to help us. 10, 20, 30, 40, 50, 60, 70. So 75 degrees is between 70 and 80. And so we're going to mark a point right here, and that will indicate to us that that is 75 degrees. So let's go ahead and mark that point. And I'll mark it in red just so that I can kind of tell the difference here. So this right here that's my 75 degree mark. Okay, so I went ahead and made that mark. Okay, so that red is my 75 degree mark, and I know that if I draw a line from P to that red, it's going to be the same distance as from P to X because I used a compass, and a compass draws a perfect circle if you do it correctly. So now, of course I can measure it, but sometimes measurements can be imprecise. So that's why you want to use your tools here. All right, and then we're going to go ahead and connect it in the straight edge here. All right, and this is just to kind of illustrate the fact that these two lines are congruent. These two line segments are congruent. And so the point that I'm interested in here, this is X prime, is this point that intersected the arc. And so we went ahead and rotated it. So we rotated point X. So there is point X right there, or X prime, and we rotated it 75 degrees. So I showed you how to do that using the tools. And next we'll go ahead and repeat this process for Y and Z to get the rest of the points. And so notice that this distance is the same as this distance, and this distance here is the same as this distance here. And they're all rotated by, in this case, they're all rotated by 75 degrees. Technically, it's 75 degrees counterclockwise, so that's positive. But then we go ahead and draw connect the points with a straight edge, and we get our triangle, X prime, Y prime, Z prime. And so we essentially rotated the triangle about point P. All right, so that's how we physically rotate a triangle and we make the measurements in place in order to make sure that it's accurate using our tools. But now we're going to talk about special rotations in the coordinate plane. So there are very specific rotations about the origin that can be done easily by using a coordinate transformation. And so all we need to do is, if we know the rule for the specific rotation, then there's no need to do the measurements that we did in the previous example. We could just simply transform the coordinates and be done with it. And so these are the three specific rotations that you should know. So if you want to rotate about the origin, remember the origin is this center point here, right? If we want to rotate about that, so this black point is the original point. This black point is the pre-image. And so if I take that and I rotate it about the origin at a 90-degree angle, so notice that that's a 90-degree angle, then I get a new point, and that new point, if this coordinate is xy, then this new coordinate is going to be negative y x. So basically what I have to do is I have to switch the x and the y coordinates, and then the y coordinate is going to be negative. Okay, so basically I make the y coordinate negative and then I switch the x and the y. So for example, if I'm doing a rotation 90 degrees about the origin of the coordinate 2, 5, well then in this case, in this case, I would have to make the y negative. So this 5 is going to be negative, and then I'm going to switch it. So it's going to switch with the x, and then y is going to be negative. And that would be the rotation 90 degrees about the origin. And so once you know the rule, you can apply this to all the points in that triangle or whatever shape you're rotating. And so for the next specific rotation, if we're rotating 180 degrees about the origin, then you're simply going to change the signs of the x and the y. So if this coordinate right here, this coordinate is actually 1, 2, then this coordinate right here is going to be negative 1, negative 2. And so we know that the rotation 180 degrees about the origin of 1, 2 is going to be negative 1, negative 2. And so if now the third rule, if you rotate 270 degrees, well, this coordinate is 1, 3 or 1, 2. Then according to the rule, you're gonna negate the x. You're gonna make the x change the sign of the x, and then you're gonna switch x and y. So I'm going to then this coordinate right here is to negative 1. So the rotation of 270 degrees about the origin. And remember, this is a positive angle, so this means that you're doing it counterclockwise. So these angles are all counterclockwise. So rotation 270 degrees about the origin of the coordinate 1, 2. Well, you're going to switch the x and the y and then negate the x, or change the sign. And those are your special rotations. All right, so let's look at an example of rotating. We're performing the transformation on this quadrilateral ABCD. Remember, a quadrilateral has 4 sides, which in this case, this has 4 sides. We have 1, 2, 3, 4. This is referred to as a quadrilateral, quad meaning 4. And so we want to be able to rotate this. We want to rotate it 90 degrees about the origin. So this is the origin right here. We want to rotate it about that origin. So again, we can use the compass and the measurements to do this, or we can use the special rotation rule. For the rotation rule for rotating 90 degrees about the origin, so if we're rotating a point xy, well then the rule for the rotation is that you're going to switch the x and the y, but the y is going to be opposite in sign. Okay, and I'll go ahead and show you in that slide so you can refer to it. 190 degrees, negative y, and x. So we're going to be using that rule here. And so if we wanted to do it for point A, point A is 3, 5. Well, in this case, we make the y negative, and then we switch the x and the y. There you go, we get negative 5, 3. And we'll call this a prime. So we'll go ahead and plot a prime here. So negative 5 and 3. That'll be a prime. And just in case, just so we have enough room, I'm going to continue this over here. So let's do the coordinates for b. B is 1, 7. So, and we'll show you the arrow notation here. So that way you can get used to the arrow notation as well. If we want to take that and we want to rotate it, we want to do a rotation of that, then it's going to be negative 7 and 1. Okay, and that would be b prime. All right, we'll do the arrow notation for C and D. So the coordinates of C are negative 2, 4. So you're going to change the sign of the y and then switch x, y. And lastly, and this will be C prime. And then lastly, we have D, which is 2, negative 1, and that's going to transform with the rotation. It's going to be negative 1. Oops, it's going to, the sign of the y changes. So it was negative here, so it's going to be positive now. And we switch x and y, and this will be 1, 2. Okay, so notice that the y changed sign from negative to positive. All right, we're ready to plot the points here. So we have negative 7, 1 right here. This will be my b prime. C prime's negative 4, negative 2. And D prime is 1, 2. So right here. So I want to make sure that I'm able to connect these. So I'm going to connect these the best I can. You would connect these with a straight edge. But we'll do the best I can. Well, we'll just do this. Okay, so there's CD, BA, BC, and then A prime, D prime. And so you can see that this figure has been rotated a full 90 degrees. So you can kind of imagine that this has been rotated full 90 degrees about the origin, of course. And that's how it would look like if we rotated it. All right, so now let's look at one theorem and to close off the lesson, and that's the rotations and reflections theorem. So any rotation can be considered a composition of reflections across two lines that intersect at the center of rotation. This is key here. The lines of reflection have to intersect at the center of rotation for this to work. So the angle of rotation is actually going to be twice the angle formed by the lines of reflection. So let's say we have a generic angle x and we're rotating that counterclockwise. And so we're rotating A get to B about the center of rotation P. So what I can do is I can take any two lines of reflection, in this case M and N, and I can draw them, and these lines have to cross through point P. So I can take any two lines and cross them through point P. And as long as the lines have a certain angle, let's call it Y, then that angle is going to always be half of the angle between, in this case, this side and this side. So for example, if the angle here is 35 degrees, well, let's do something easier than that. So let's do 50 degrees. So if that angle were 50 degrees from B to A, and I were to draw any two lines of reflection, and I drew them, and I had to draw them so that they're 25 degrees apart. and the lines have to cross their point P. And so I have to draw these so that they're 25 degrees apart. Now, if they are 25 degrees apart and they cut through line P, then that means I can take any point, example point A, and I can reflect it across this first line, and then I can reflect it across the second line, and then I will get point B. So basically, it's very specific. The lines of reflection have to cut through the center of rotation, and they have to be half the distance apart, half the angle apart that it is from, these guys, and then from the original angle. And then if you do that perfectly, then if you reflect it across those two lines, you'll get the other point, get from A to B in this example. Okay, so that's what this rotations and reflections theorem states. This is not an official name. This is just what I called it. It's a theorem in the book, but has no name in the book. All right, so basically, like we said, we can consider two rotations, very specific rotations about lines M and N that have to cut at this specific angle to be the same thing as doing a rotation. So basically, if we have two lines of reflection like this, we can just consider as a rotation and basically just collapse them and just call it a rotation. Okay, so we'll go ahead and show you an example of how this works. So what we want to do here is we have the image and the pre-image. So in this case, this is the pre-image, and this is the image. So the image is the product. Pre-image is the before. And so we want to take that and we want to rotate it, get the other guy. And so this is definitely a rotation. However, we want to figure out, well, how can we consider this as two reflections? Okay, so we know it's a rotation of 115 degrees clockwise because it's negative. So this is clockwise. And so how would we consider it to be a reflection? Well, first off, we know that the angle between any of the 2 points, and this should be from here to here rather, we know that the angle between any of the 2 points, if we were to draw an angle, a line from T to a point and then T to the corresponding point, that angle has to be 115 degrees clockwise. All right, so then what we do is we can draw a line. As long as that line cuts through T, you're fine. Okay, so this is line M. This line can be drawn anywhere. So this line could be drawn here if we wanted to, but I just arbitrarily drew it there, okay? And so now I want to take that line and I want to measure it so that it's exactly half of this distance. Remember that angle was 115. And so I'm going to have to take that angle and cut it by 2, that entire angle, and I'm going to divide it by 2, and that will give me 57.5. And that will tell me, well, okay, I need to draw a line that is 57.5 degrees away from line M, using the protractor, of course. Measure that angle. Once you measure that angle with the protractor, then you can go ahead and draw the line that cuts through T, and that will be your other line of reflection, N. And that is it. So those are my 2 reflections. And so what I want to do is I want to illustrate to you, that if I were to reflect this original pre-image, if I were to reflect this across these 2 lines, that will result in the product on the left side. So let's show you the first reflection. So remember, a reflection has to be the same distance on both sides. So we're going to go from K to K prime here, from J to J prime, from M and L to M prime and L prime respectively. And so they're a perfect reflection on the other side. We can connect those 2 and we got a perfect reflection. And so now I'm going to perform a second reflection across line N. And so the distances on both sides have to be the same for each of the points. And so there you go, I get my perfect reflection. And so basically, by doing these 2 reflections, I was able to get a rotation from here, there, at an angle of 115 degrees, of course, clockwise. And so this illustrates that a rotation can be considered as two reflections if performed in this manner. All right, guys, that is it for the lesson. Thank you for watching the video. I hope you took something from this, and as usual, I'll see you in the next one.